Good morning, guys. Welcome back. We will continue with our AWS session. So today is AWS day 6 session, and today the date is 29th of your November 2025, and timing is morning 8:05 a.m. IST. Okay, so guys, like we have not yet started with anything with our AWS services, right? We are only doing some basics only, right? So today I think would be the last day for our basics. So from tomorrow onwards, we will try to cover the first AWS service, which is AWS networking. So we'll start with the VPC. Okay. So, right. So let us see what we will be covering today's session. So today's will be a quite interesting session because we will be covering something about the subnetting, right? And why we need a subnetting and all. We will be understanding that, and also we'll take some few examples of how you can know select any kind of a network and how you can create a subnet. So whenever you come across with something like designing the network, and you have been told to design a network so that it can accommodate some number of devices or something like that. So you need to choose a network, right? Basically you have to choose some private IPv4 address CID range, and once you select a private IP address CID range, then you will start creating the network. And for that to come up with the subnetting, right, to come up with the entire network, and you need to divide it. Basically we do something as a subnetting actually, right? Subnetting is something where we are dividing the whole network, right, into smaller networks. That we call the subnetting. Now, before we start getting into the today's session, let us try to check what we did in the last session. I think in the last session, probably we had some basic understanding about like how to come up with a subnet, right? If you remember, sorry, subnet mask, right? If you have been told that okay, there are so many number of devices are there in your so many devices you have to connect, how you are going to come with the subnet? That is what we had discussed it actually, right? If suppose some of you have missed it, I would request you to go through it one time, the day 5 session, or else we can take today one more examples we can take so that we will be able to understand. Or else in the last session I had told that okay, please create a network of a size 50 devices or 12,000 devices, right? This is something I had given an assignment to you all, right? We'll quickly recap all these things like how to do it actually, right? Now for example, now the question comes that Rajesh, I am been given like to connect like 12,000 devices. This is what the devices I need to connect, right? So how we are going to do it actually? So we know that like in the last class we have, if you remember, we had divided with one of the formulas, the 2 to the power of n, okay, minus 2, small n, sorry, minus 2 is equal to we are equating to the number of devices. This is what we had covered in the last session. And if you remember, we had even discussed that actually your can say that small n is nothing but what is it? It is consecutive zeros actually. Consecutive zeros is small n. Okay, consecutive number of zeros actually. Consecutive number of zeros is nothing but the small n, and capital N is something like consecutive number of ones. Right, guys? Now, if I try to calculate 2 to the power of n is equal to 12,000, right? Now, if it is, so it means that I need to come up with a subnet mask where what happened, right? Like I need to calculate, right, for 12,000 devices, what should be the subnet mask which you have to derive so that it can accommodate 12,000. So now 2 to the power of n is equal to 12,000. Now, so what should be then? So what I will do that I'll go with the net and I will go with the 2 power table to just to understand what would be the nearest n value, right? If I go to this table, and as I said, right, like if you go through it, you have 12,000. So you need to just see what is the nearest value. Like for example, if you see it here, if you come down here, which is the nearest value? 8,192 is less than 12,000. Okay, I can't go with that actually. Okay, what about the next? Next is nothing but your 16,384. So 2 to the power of 4 is 16,384. 84. That is what the nearest value which I can go with, right? So the n value here, it is 2 to the power of 14. So n value is 14 actually. If the n value is 14, small n, capital N is what? What is the formula? 32 minus small n, which is nothing but equal to 32 minus 14 is how much, guys? You're going to
18.
get the value 18 value.
18.
Yeah, 18 value, right? So now your subnet mask will be, so 18 ones and sorry, yeah, 18 ones and 14 zeros actually, right? So it will be 1111 okay, 18 ones. So 8 plus 8, 16.
32 bits.
Yeah, and dot 16, 17, 18, and then remaining will be zeros, 14, like 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, dot 1, 2, 3, 4, 1, 2, 3, 4. This will be the subnet mask value, right? So if you try to convert it into the decimal value, it will be 255.255 dot. How much is this one? If I try to copy this,
192. 190.
yeah, 190 only, right? Yeah. What would be the decimal to, sorry, binary to decimal converter, right? Yeah, you'll get 192. Yeah, this will be the one value 192, and this will be the entire zero, right? This will be the subnet mask if you want to connect 12,000 device in your network. How to choose and all, we will see it later. But, right, similarly, I can go with an example of one more example. Just to brush up, guys, I'm doing it actually, right? Now, what is it? Next is how much is one? How much is a device? 8 devices, right? So I need to connect 8 devices. So please, sorry, calculate what will be the subnet mask, right? So here you know very well that a small n is nothing but consecutive number of zeros and capital N is nothing but consecutive number of ones. We know this formula. We know this actually. And the formula is nothing but 2 to the power of n, okay, minus 2 is equal to the number of devices what you can connect actually. This is the formula actually. Right, guys? So here, all this is what happened, right? Like we were calculating 2 to the power of n minus 2 a number of devices. The number of devices was, the value was so big actually, we were discarding this minus 2. So we said that, okay, we don't consider it. So that's what we just arrived saying that 2 to the power of n is equal to 12,000. But since here in this case, the device is very small, is, I mean, the number of devices what we current is very small in number, we have to keep it this minus 12, right? We cannot discard this now. So now what happened, right? 2 to the power of n minus 2 is equal to number of devices 8, right? And then that is equal to 2 to the power of n is equal to it will be 10 actually, right? Because your 2 will shift to here to the right side, it will become 10. 8 plus 2, it will become 10. So now what I'm saying that now what we are seeing that actually we have to connect 10 devices. So what should be the n value if it is, if it is 10 actually? If it is 10, so if you 10, you could see that actually you cannot go with 2 to the power of 3 because it is 8 actually. So 10 is sorry, 8 is less than 10. So the next higher value is 16. I can go with the 2 to the power of 4 is 16. So here I'm considering n as is equal to 16. Am I clear, sir? Right?
Yes.
So 1 second, guys. What is it actually? How much devices we are connecting? 10,
Devices.
no, no, 2 to the power of 4. Yeah, n is how much? Not 16, 4, sorry. 4, no, 2 to the power of 4.
Yes.
4n is the value, right? So now if it is 4, what would be the capital N? It will be 32 minus n, right? Which is nothing but 32 minus 4. What is the value, guys? You're going to get 28, right? So n will be your subnet mask will be 28 n's, 28 capital 28 ones actually. So 28 means how much? Uh how much is it? 8 plus 8 is 16. 16 plus 8 is 24, 24, 25, 26, 27, 28. And remaining will be 0, 0, 0, 0. This will be the subnet mask. So n is 4, small n is zeros is 4, and capital N is 28. So if you try to convert into the decimal, it will be 255.255.255 dot how much is the value? We copy this, go here, and then just see the value is 240. So this will be the subnet mask if you want to connect 8 devices in your network. Am I clear, sir? So this is what we had learned in our last session actually. Right, just we derived with a simple formula 2 to the power of, and then like we try to come up with a subnet mask. Okay, now usually what happens guys in a industry, usually whenever we are denoting anything related to the subnet mask and all, right, they provide you a kind of a notation, we call it as a CIDR notation actually. Like for example, in an organization, what they do, right, they will give something like this: x dot x dot x dot x dot x slash n, like this they will give you. This is the CIDR notation we say actually, right? This is a CIDR notation. Okay, and we know that what is capital N in this case? Here capital N is nothing but your consecutive ones, right? Consecutive number of ones, right, is nothing but capital N. Right here, whatever the denotation, whatever the notation you're seeing, it is nothing but the consecutive number of ones only. That is what it is called. Right. Now, for example, if I give an example of like 192.168.0.0 slash 24. So this is what nothing but the CIDR notation they'll give to you. So if they give this way, so what you need to understand that with the CIDR notation, you should be able to come up with what will be the subnet mask. What will be the subnet mask? Here, if you see this value 24, which is not but capital N, it is not but 24 is nothing but the consecutive ones, right? Correct, guys? It will be consecutive one. If 24 is a consecutive ones, right? What would be your small n?
8.
8, right? Yeah, 8. Right. So how we are going to come up? Your subnet mask is nothing but is equal to 24 n's, right? So this is 24 n's like this. 8 plus 8 plus 8, 24. Like this. Dot 0, 0, 0, 0. 1, 2, 3, 4, 1, 2, 3, 4. Like this. So this value you're going to get is nothing but 255.255.255.0. This is 255, this is 255, 250, and this is 0. So this will be the subnet mask. So when you're getting this kind of a CIDR notation, you can easily calculate what would be the subnet mask actually. Correct, guys? So this 111 is always fixed, right? You cannot do any change, right? Only this is the only value which is nothing but the network ID. This will be keep changing, right? So it means that what would be the least value and what would be the highest value? The least value will always be for the 000. We know that 1, 2, 3, 4, 1, 2, 3, 4, right? And the highest is 111 only, right? 111, 1111. So the value will be ranging from 0 to 11111. All ones are 255. So here what is happening that here, if you're having this IP address, and if your CAD is like something like they have given 24, it means that in this network IP address you can connect up to 255 devices. Right. So 255 means you can discard two IP addresses like 192.168.0.0 and 192.168.0.255. Those two IP addresses you can discard. Remaining all other can be assigned to 254 devices actually. In that way, you will be able to understand if you are getting this kind of a CID notation in the organization. Correct, sir? Am I clear on this? Okay. Now, any questions you have here? For example, assume that one more, we'll like take an example of one more, like simple, we'll take 192 192.168.0.0/16 if they give it. So this is nothing but your capital N, right? Capital N, right? Now, when I'm giving like this, just you have to consider this as an IP address only. Okay, so it means that Rajesh, this IP address is coming in this particular range actually like this. So the IP address is what you're getting. This is the IP address you're getting. Okay, since the N value is 16, it means that it is consecutive ones. Consecutive ones. Consecutive ones is always fixed value. You cannot change it. So in this case, what happened, right? This 192.168, these are 16 values. This will never get, this will always be fixed. Only this two, the third octet and fourth octet will change because these are small n, right? So here what happened, if the n is 16, then the small n will be 16, right? Because 16 minus 32 minus 16 is how much? How much, guys?
16.
16 only, right? So in that case, what would be the subnet mask? So it is easy, quite easy, right? It will be like 16 ones and 16 zeros, right? This will be 16 ones like this and 16 zeros like this, right? So the value is 255.255.255, sorry, dot 0.0. So your IP address range will be 192.168 dot 0.0 to 192.168.255.255 like this. Am I clear, sir? So how many devices you can connect here? You can connect up to how much? 16,000. How much you can do? 255 of to how much? It will be 65,536. Like that much devices you can connect if you in this IP address actually, right? Okay, sir. Good.
Okay.
Rajesh,
Hmm.
I didn't get this 16. How we are getting that 16, bar 16? Go up
Hmm.
here, 192.168.0.0.
Hmm.
Till calculating the assigning the 12,000 I got. After that, how that 16 we have taken?
No, no, this is the CIDR notation I'm saying. CIDR notation.
Okay.
Okay. Did you understood the previous example? This one?
Yes. I got it. That I
Hmm.
got it.
Same thing here. This is nothing but the same thing. Instead of 24, now this time I'm taking example of 16.
Okay. And
So
now we
what
are,
now what is this 16 means called as per the notation, this is capital N, right?
yeah.
So capital N is what? It is consecutive ones. Ones. Right? If the N is ones, what would be a small n? It would be 16 only, right? Because
Yes.
yeah, so if capital N is small, this one and small n will be one, so it means that actually capital one means consecutive ones. It is not about 1 1 1 1 1, and the small n is 0 0 0 0 zeros actually.
Okay.
So this is fixed. We cannot do any change here. So the first octet and second octet will be fixed. These two values will be fixed in this IP address. Only these two
Okay.
value will only will get changed because this is 0 0 0 0 zeros.
Okay.
Right. So here the value range will be 192.168.0.0 to 192.168. Maximum value is 255.255 like that. This will be the range what you're going to get it. If this is what if you are given this as a shared notation to you like that.
Okay. Got it.
Now the question is that actually that see when you see this kind of a shared notation, it is good actually because you are seeing like whenever you are seeing anything like shared notation as 24, 16, 8 like that, our life will be very easy because this whole thing, this any one of the octet, any one of this octet, it will be either zeros completely or it will be either ones actually because you're getting if you're taking this 24, 16, and 8 actually. Suppose, for example, if you're getting some other value apart from that 24 or 16 or 8, like for example, if you're getting a value like 20 or 22 or 21, then it will become little bit tricky actually. It will become little bit tricky. Like for example, I'll take one example.
Yes, one doubt.
Yes, sir.
In that son, like last one, 192.168.0.06/16,
Hmm.
you get IPs. How many IPs means 255 into 255 equal to
Hmm. So see here what happened, right? This is the starting range. That means that it will start, and you can have up to this many IP addresses actually. Like for example here, see for example how you are understanding. Like for example 192.168.0.0. This you can skip it actually.
mm,
Okay, you cannot assign to any device, right? The next will be 192.168.1.0. This will be the first one. 192.168.1.1.
one
192.16, sorry, this is 168, right? Sorry, right? 192.168.1.2.
dot.
Yeah, like that, what happened? Like that, what happened? You will come across with some other IP address like 192.168.1.255. Am I clear, sir?
Yes.
Right? Correct?
Yeah.
Now the next is 192.168.2.0.
Dot.
But 2.0 we won't assign it. Then we'll
Okay.
assign 192.168.2.1, like 2.2, 2.3, like that 192.168.2.255.
Okay.
Like that will be keep going. One time will come where we'll give 192.168.255.0. 192.168, sorry, 192.168.255.1.2, like that. 192.168.255.254, like that. This is the last IP address.
Rajesh, one more question. This 192.168.0.0, we will skip that. That's the first, this one.
Hmm.
But next one will should be 192.168.0.1, right?
No, yeah, that's what you're saying is right
Yeah.
actually. 0.1
Yeah.
only. 0.1, 0.2, like that.
Okay.
After that, you will get this one, right?
Okay.
Like that.
So that two IPs you told that one is for the host IP, one other one we will last two IPs we will skip. That is the first.
190.1.0, yeah. Last what you're going to get is 192.168.255.255, right?
What we call that?
Yeah, this is called a broadcast actually.
Broadcast. And the first
Yeah.
one is
First is nothing but it is for the network ID.
network IP. Okay.
Yeah, we will not give that to any device actually. This and this
Oh.
one we exclude it. Remaining all we can give it to all devices.
Okay. So if it is
Dot C.
a 2 to the power of it is a multiple of 8, it is easy to find the IPs.
Multiple at anything, sir.
The
That's
not,
what I'm saying
yeah,
that
yeah,
if it
multiple
is
of,
20,
yeah,
yeah, if it 24, 16, 8, it is quite easy to calculate this actually.
yeah.
Now
No,
what I'm saying means if it, yeah, some question.
we have to skip 1.0, 2.0 also we have to skip, I think.
Yeah, because you have to skip even that also, right? You have to skip even that also. No 9.0, 3.0, 4.0, 5.0. Yes.
2.55 also we have to skip, bro.
Yes. Obviously, you have to skip even that also. Okay.
Why?
Now, hello? Yes, sir.
Why we have to skip that 1.0,
No. Assume
2.0?
that in one floor you are using this one. In the second floor you are using the second this one 1.0 in the 2 dot series. In the second floor you are skipping the 2.0, and in that second floor you are also skipping 2.52, 55. You are skipping
Okay, okay.
like that, something like that. Now, what I'm saying that your life become very simple. Like if you're having this notation of 16 in the 16 or 24 or 8, like that actually. Suppose in case if your CID range is like this, CIDR notation, something like this. For example, you're having 192.168 what is it, 0.0. Let me take some example of 20. I'll give 20. Right. Now the thing is that we know that capital N is what, sir? It is 20, right? It is not but consecutive ones. Small n will be how much?
12.
12. Yeah. So it means that your subnet mask, SM is subnet mask, will be 20 ones actually. So I'll take this one. I'll copy. Let me copy this. 8 plus 8 is 16. 16, 17, 18, 19, 20, right? And then remaining will be zeros. 1, 2, 3, 4 dot 1, 2, 3, 4, 1, 2, 3, 4. Am I clear, sir? So here, what is happening is that actually that here, because the value here it is 20 actually, right? It is little bit differing here because here what happened, this is fixed actually. 190.160 dot is fixed actually. This is fixed actually. In the third octet, what happened? Earlier we used to see either one completely ones or completely zeros. Right? Here either completely zeros or we used to see completely ones actually, something. But here what happened? It is a combination of one and zeros now. Am I clear, sir? And the third and the fourth octet is anyhow it is zero actually. Right? Now how to calculate this one actually? Now the thing is that actually this 20 ones we cannot change, right? Even in the third octet, even we cannot change do the changes also. This is fixed actually because capital N is always fixed. So capital N is 20 bits, which is number this entire bit is fixed actually. Correct, sir? Now what happened? I have to only play around these four values. 4 bits actually. And this will be what? It will be least will be 000, max will be 255 to 255. So that we are aware of it actually. Now, how to come up with this? What is the formula? How we are going to come up? You'll say that Rajesh, the IP address is 192.168.0.0 I mean, I'm just taking this one, the complete one. But since we are having a notation of SATA of 20, which is nothing but 192.168, this is fixed actually. But here in the third bit, it is something getting changed here actually, which I'm not aware of actually. Just I will equate to X like this. Right? And even this will also get changed because this will be either 000 or 111. Even this also will get changed. I'll just equate to X like this. Is it fine, sir? Right? So now the thing is that here, what is happening there? So it means that Rajesh, what is the range I'm going to get it like this? So in this case, I'm going to get a range like 192.168 dot this X dot of this wall will be 000. I will consider as a 0 to 192.168 dot X of I will get 255. Correct? Because this fourth octet will be either 000s or 1111. So 000 is 0, 111 is 255. Am I clear, sir? Am I clear, sir, till here? Now the thing is that here we are having only 4-bit value. This 4-bit value. I'm sorry, share. This 4-bit value. This is the only thing which I have to consider because this will be either, this will be it will be either it will be 0 or it will be 1111. Am I clear, sir?
Yeah, last octant also zero, no? Last you have
Which one? This one. This I'm making a 0, no?
But 255 also.
255, 1111, no?
Okay.
Right? Now the thing is that actually, like, if it is 00000, okay. So here 192.168 dot so here this is a 0, okay, because the third octet is 0 as per the IP plus X, okay, dot 0 to 192.168 0 plus X dot 255. Right? So in this means, Rajesh, it is 192.160 dot. Because this X will be either 000. We know that 000 is what? 000 is 0 only, no? So plus 0 dot 0 to 192.168 dot 0 plus what will be 11111 value, guys? What will be the 4 values?
1.
No, no. If you go to
Sorry,
the
Is 224 plus 240.
no, just one. Come on, what happened, man? It is 15 actually. Right? So it will be like this 0 plus 15 dot 255. So it means that it is 192.168.0 plus 0 0 dot 0 to 192.168.15 plus 0 is 15 plus dot 255. This would be the range actually.
Rajesh, it is actually triple one, 4 ones after zeros value you have to put now. Four.
Sir, here what happened? Now this is fixed, sir. We won't touch it because this comes under the capital N, right?
Hmm.
So this we don't touch it. We only play around with this only. Because here what happened in the third octet, we got a combination of ones and zeros, right? Then what happened? This 1111, you can't touch it. You won't touch it because this is a capital N. It is fixed. Only this four zeros only will change it actually. So it will be
Okay.
either 0000 or it will be either 1111.
Okay.
So 4 ones is how much? It is 15.
Okay.
So here what happened, we are having already third octet is 0. 0 plus 15 is 15 only. Here 0 is there. 0 plus 000 is 0 only. 0 plus 0 is 0 only. So this is what you are going to get actually. Am I clear, sir?
Okay.
Now, if you are trying to go to the internet and then you just try to go and just try to check it like CIDR expander. You can go to any one of the utility. Right. Now, if I go here, you could see that this is a CIDR. If I try to copy this CIDR like this, paste it here, calculate it, you will get what is the first IP? 192.168.0.0. What will be the last IP? 192.16.15.255. Right, sir?
Yes.
Yeah, this is what you got. So, as I said earlier, right, if your life, if you, it is 24 or 16 or 8, right, 16 or 20, then our life become very easy. If apart from that, like for example, instead of 24, 16 or 8, if you're getting some other value, right, then what happen? Then you need to calculate actually, right? Can I take one more example? Suppose you're having, suppose you're having a CIDR of something. I'll take in the class B 172.16.0.0. Let me take some value like 12. I'll take it. Am I clear, sir? Now what happened? This is what it is. I need to calculate the subnet mask. Right? How to calculate the subnet mask, right? So for example, you will take consider this as a complete IP address itself. Okay. Take this complete IP. This itself you are taking it here. Right? Now, this is capital N, right? So capital N is not but what is capital N is 12, right? Am I clear, sir?
Yes.
What would be the small n?
20.
Yeah, 20. 20 is small n, right? So here your subnet mask will be 1, 1, 1, 1, 1, 1, 1, right? How much is 8 ones? 8, 9, 10, 11, 12. 12 is nothing but your capital N. Remaining all other will be 0. 1, 2, 3, 4. Dot 0 dot 0 dot 0. This one. This is the third octet and fourth octet. Am I clear, sir? Till here? Now, here what happened? The first octet, the third octet, and the fourth octet, we don't have any problem. It is either 111 or 000. Only the problem is with the second octet. Correct, sir? Second octet. Now, how we are going to do it? So we know that Rajesh, this capital N is 12. This is fixed actually. I cannot do it. It means that 172.16 is something like a fixed, but it is not. But this octet has four values, which is showing 0 actually. It should have been either been everything 111, then it would have been easy for us. But since it is a combination of ones and zeros, then now we need to calculate properly. Am I clear, sir? Now, how we are going to, what would be the range? Like, for example, like your IP range will be something like 172, right, dot 16, 16, right? Because this is a second octet, right? 16. Here, what is happening that actually that you have to say of X actually. X is something like this is what the X. We consider this 4 bit as X, right? And what will be the next value? It will be 0.0, right? To 172 dot 16 of what is it, x dot, the highest value will be 255.255. Am I clear, sir? Is it fine, sir?
Mm.
Now it's the same thing now. Now, for example, here what happened, right? 172 dot 16. Because if this considers a 4000, so what will happen, right? The formula will be something like this. 16 plus of x is what? It is 0 only. Right? Dot 0 dot 0 to 172 dot 16 of x is what, sir? X is what? The if everything is 111, it will be 15, right? 15, right? Like this. So the final is nothing but 172 dot 16 plus 0 is 16 dot 0 dot 0 plus 172 dot 16 plus 15 is 31 dot 255 dot 255. So if I try to copy this, I'll go to the CIDR expander. See, the first IP address is 170.16.0.0. The second is 17, the last IP address is 170.31.255.2. Am I clear on this, sir?
Yes.
Right?
So you are converting the binary to decimal, right? That 1141s.
Yes, obviously, because this 4 only I'm considering. This will, the least value will be 000. The
Yeah.
last value, the highest value will be 1110. All ones are nothing but 15, right?
Yeah.
If you convert the binary 111 to the decimal, it will be 15, right? So 15. So here what happened? This is the second octet, right? 16. So I'm adding that 15 with the 16 actually. So I got 31. I added the same with the 00. So 16 plus 0 is 0. 16 plus 0 is 16 only, right? So this is same, but whereas this value will be different because you have to add the value of this octet 16 with the whatever we got it, the decimal value, right? When you're having 111, right? That is 15, right? So 16 plus 15 is not 16 plus 15 is 31 actually.
This will be the part of interview, Rajesh.
100%, sir. 100% will be a part of interview. So guys, can you calculate now exercise for you assignment? You can do it later. Please get it 192.168.0 sorry, 128.0/20 and 10.64.0.0 sorry 64.0.0/14. You can do it later. Okay, this assignment you can take it and you just try to do the same way as I did it. One second, guys. I'm getting one call. One second. I will just pick the call. Oh, sorry, guys. Okay. So, fine. So, shall we continue now? Okay. So, guys, now what would be learning now? We'll be understanding some few basic concepts about I mean a few things about the subnetting and all, and then like we will try to take a problem statement of saying that okay, I have this kind of a requirement. How we are going to come up with a subnet, right? That's what we will be learning. So, just give me next. 1 to 1.5 hour of time, guys, so that I'll be easily completing everything. Okay, today our session might get extended beyond 2 hours, but please try to bear it. I will try to complete before itself, but still try to bear for some more extra time, so that I will complete this session today because I don't want to really continue in tomorrow's session. tomorrow we'll start with the VPC, right? So that's the reason I thought like let me complete all the concept today only, but let us slowly do it so that you understand everything. Okay. Now the thing is, guys, we have learnt about some basic aspect of what is network and networking is all about, right? So basically, whenever any two devices they connect in the network, and whenever they want to do a communication between them, right? That is we call it as a networking actually. Right, and whenever we want to communicate between the two devices, basically we need to get one IP address. Each and every device should get an IP address, and that is what we call it as a virtual IP, or we just call it as an IP address actually, right? So usually what happened, right, we have two different of IP addresses. One is a private IP address, right, and other is a public IP addresses, correct? Right, private IP address and the public IP address, these are the two different types of IP addresses you will find. Am I clear, sir? Now we know that private IP addresses are always free IP addresses. You can use it actually, but whereas a public IP addresses are the paid one actually. These are paid one. Usually organization, whenever they need any IP addresses, right, public IP addresses, they'll go with the paid IP addresses. They have to pay pay the amount for getting IP address. So usually what happened, whenever the system administrator he requests, okay, I need a no, I need an IP addresses basically. So you will go and you will try to you will try to go and allocate an IP address for your requirement actually. So you will know that in an organization, right, they will be having a lot of public IP address because they want to do so much communication over the internet, right? So they need a public IP address, right? And this public IP address, it is assigned by your, like it can be assigned by internet service provider, or you can even go with INA, right? Internet assigned authority, right? That organization, they provide all these public IP addresses, right? And there is a public IP addresses ranges are also there, right? You can get the IP address from any one of the public IPv4 ranges actually. Clear, right? So, right, and then like what happened basically, like usually we use basically we use two version of IP addresses, right? We know that we have a two versions of IP address. What is the two versions? Basically, we have a IPv4 address and IPv6 address, right? So IPv4 address, you know that it is 32-bit address, or else you can call it as a 4 octet, right? Because each octet is 8 bits, so 8 fourths are 30, so it's a 4 octet. Right? Similarly, your IPv6 is a 128-bit IP address, right? So we will discuss about the IPv6 later, not now. Okay, when I get into the AWS networking and many things, right? I will be touching one topic where I'll be showing, I'll be discussing more about the IPv6 addresses and everything. But right now we will not be discussing anything. Whatever we are doing till now, we are only playing with IPv4 address only. Let us try to stick in the IPv4 address mode only. Okay, guys. Now we know that IPv4 address is number 32-bit address, and we know that actually, like whenever you see any IP address, it will be 4 octet like this. If I'm taking an example of like this, actually, it's a 4 octet, right? Because each is 1 octet actually. Each one is 1 octet. So 1 octet is nothing but it is a 8-bit actually. So it will be 32 bits. So this is how it is represented. Whenever you see IPv4 address, it is having with the 4 notation, right? X dot X dot X dot X, right? Like that, right? Right? So now what happened, right? This IPv4 address, right? So IPv4 address, it uses 5 different classes of IP address. So what are those 5 classes of IP address? You know that there is a class A, class A, class B, class C, class D, and class E. These are the 5 class of IP addresses are there, right? Your IPv4 address, it can use any one of these classes of IP address. Either it can use class A, class B, class C, class D, or class E. Right? Now, how do you recognize whether your IP address falls under this class, whether it's a class A, class B, class C, class D, class E? How you will understand it? Because you know that the IP addresses, the first IP address, the first octet, what are the first octet we have, right? The first octet, what we are having. With this octet only, you'll be able to understand what is that IP, in which class it is coming under, right? So, in IPv4 address, the first octet will always, sorry, the first octet will always represents the IP address class actually. Do you agree with this, guys? Right? And we also know that each octet is an 8-bit actually. It's an 8-bit. We know that each octet is 8-bit. So each octet is 8-bit what? Each octet, we know it very clearly. It is 8-bit. 8-bit. So at 8-bit means what? 8-bit is something like the least value will be 0 and the maximum value will be 255. This we are aware of it. Right? And also we should know very clearly, guys, that for example, whenever we are giving any IP address 192.168.0.1 like this, I'm taking example, we should be able to know how to convert into your binary actually. Right? You should be able to easy because now onwards what happened when we come up with the networking, we should always think about the binaries actually, right? For example, if it is 192, what will be the 192 binary? 0 0 1 2 3 4, right? 168 is a what value? 1 0 1 0 1 and remaining 3 is 0. Like this one is completely 0. And this one is nothing but what? 1 2 3 4 1 2 3 4 like this. This is a binary value for this IP address. So you should be quickly able to come up with a binary. Either you can mentally calculate it or else you can take it like this and you can calculate for each bit what is the binary value. You'll get it. What is for 68? This is a binary value. What is for 0? It is 0 in your. 1 is something like 0 0 0 and the last and the least significant bit is always 1 actually. Correct? So you need to use a decimal to binary converter always. Right? All else what happened, right? There is a quite simple formula. See, this is the 8-bit actually.
The 168, you are giving 10101.
Hmm. Yeah.
One all zeros.
No. If you go to the here, see, you are having a decimal and you are converting to the binary. Right? What is the decimal value? It is 168. Right? Convert it. See, 1010100. This is what the value. If you're not able to calculate it, what I'm saying that you use this table actually to convert it. I'm not saying that you should calculate. I mean, mentally you can calculate and you can do it actually, but I'm just saying it. So to make you simple understand, sir, like for example, this is 8-bit, right? So this is what 2 to the power of 1, 2 to the power of 0 is what? 1, right? 2 to the power of 2, what? 2 to the power of 1 is, see, it starts with a 0, 1, 2, 3, 4, 5, 6, 7, right? 2 to the power of 0 is 1, right? 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64, and 2 to the power of 7 is 127, 128, right? So it is something like this, right? 128 plus, what is it? 64 plus 32 plus, say, 32 plus, what is it? 16 plus 8 plus 4 plus 2 plus 2 plus 1. If you calculate, it will be 255. So I'm just saying this, it starts with the, it starts with the 0, 1, 2, 3, 4, 5, 6, 7. So the value is, it is, because it is a binary, you have to always use 2, right? 2 to the power of, right? 2 to the power of 0 is 1. 2 to the power of 2 is, 2 to the power of 1 is 2. 2 to the power of 3 is 4. Like this, you will be, sorry, 2 to the power of 2 is 4. 2 to the power of 3 is 8, like this. Now, for example, if I'm taking an example of, suppose like I want to calculate the, what would be the binary of the 255 value? Oh, sorry, 155 value. What would be the 155? Now, how you calculate for the 155? You have to always take that. Suppose if you're considering 155, you say that Raj, I want to convert into the binary, right? So what you can do, you can directly go like this, go here, paste it like this. Why this site has become slow, man? What is the value got, sir? You got 100111011. Like this value you got it, right? You can, this is what the binary for 155. But you say that, Rajesh, I want to mentally calculate actually, right? I want to do it. You can calculate it actually. See, in this range, in this range, do you have any value which is equal to 155? No, right? Or less than 125? Yeah. So you're having 128 is actually less than 125, 155. Yeah. Because we don't have any 155 value, right? We will go with less than 155, equal to or less than. So what is 155? 155 is not about 128. 128 is less than, right? So I'll minus with 128 actually. I'll first minus with 1. So 155 minus 128 is how much is the value?
27.
27. Right? Is there any value 27 here? No, right? Or is there any value less than 27? Yeah, there is a less than 27, which is nothing but your 16 actually. Right? So you'll minus with the 16. What is the value you got? 11.
11.
Is there any value which is equal to 11 here in this? No, right? Is there any value less than 11? Yeah, it is there 8.
8.
Right? You will say minus 8. What you got it? You got it? 3, right? Is there any value less than equal to 3? No. Less than 3? Yeah, 2 is there. Yeah, minus 2. You got 1. Is there a value equal to 1? Yeah, I mean, is there a value equal to 1? Yeah, 1 is there. Oh, minus 1. Right? So now what happened, right? Whichever value I took, right? Like 128. This is a 128 I took. And afterwards I took 16. I took 8. And I took 2. And I took 1. So now what happened, right? This 128, whichever value I took, it will be 1. Right? Did I took 64? No. Did I took 32? No. Did I took 16? Yes. 1. Did I took 8? Yes. Did I took 4? No. Did I took 2? Yes. Did I took 1? Yes. See, this is a value. If you see it, see, you're getting the same value. Am I clear, sir? So it's like a mental calculation, I'm saying. Unless you have to really break your head, sir. Go and just go and use this table and just convert it. That's all. I want, so nobody is there to, sit and do calculation. We have a table, ready-made tables are there. Go and just try to use it actually. Am I clear, sir? Suppose you say that, Rajesh, I have one more value. Okay, now do a mental preparation for what is it? Actually, 254. At 254 easy, right? What is the 254 value? Only this last significant bit will be 0. Remaining all will be 111, right? Because if you calculate completely, it is 255. You are saying 254, it means that this you can discard it, right? So this will be 0. Remaining all will be 111, right? Like say this will be 1111, 1110. This is what the value for 254, right? Right. If you go here, see, you'll get all ones. This will be 0, remaining all ones. Right?
Mm.
Yeah, like this. Sometime you spend in calculating like this, so that you will get some picture actually. Correct, sir? Now the thing is that actually that now we have a classes of IP addresses. As I said, right? Like we have a class A, class B, class C. We know that classes of IP addresses. Right? So we know that there are the class A is there actually. Now, if you see the class A, the class A, the range is from between 1 to, what is it, 226 actually. If you see the table now, it will be 1 to 126. It means that it starts with the 1 dot, something like this. It starts with the 1.0.0 and up to, it will go like 2.0.0 like this. 1.0.0, 2.0.0 like that, up to, it will go up to 126.2.0. Sorry, 126.0.0. This is the range actually, right? This is about the class A. What about the class B, sir? You can open the table actually. It starts from 128 to, what is it actually? 191. Right? Class C IP address, it will fall on from 192 to 220, 223, right? Class D IP address, 224, 224 to 239. Class C IP address, Class E IP address, it will up to from 240 to 255. This is what is the classes of IP address. Right? Now the thing is that, guys, for our requirement, basically when we are using an IPv4 address, right, we will be using a class A, class B, and class C IP addresses. We will not be using class D and class E IP address. Suppose, for example, if you're having your laptop or if you're having a desktop, right? So the desktop, or if you're having a laptop, and in your laptop, if you're trying to assign an IP address in this range, 250, 224, or in this class E, your laptop will not accept it at all. So class D and class IP address will not be accepted by your machine, right? Whereas it will accept the other IP address, like class A, class B, class C, it will take up this IP addresses. Am I clear, sir? Right? Because this class D and class C IP address, these are used for special purposes actually, right? And organization like ISRO, DRDO, NASA, they use this IP addresses actually, right? And basically, this IP addresses, they use it for their own requirement. Like they use it for something, for a purpose for multicasting actually. For the multicasting purpose, they use this class D and class C apparatus. That's what they've been reserved. All your defense organization and all your research organizations, right? They use this class D and class C apparatuses. Am I clear, sir? Now here, if you consider it, so Rajesh, where is 0 dot then 0? It starts from 1 only, no? What about 0? 0 is not used, sir, actually. Like 0 dot 0, that range, right? It is not used actually. It is reserved for default routing uh, or internet access. We don't use it actually. It starts with 1 only actually. Right. And also, if you watch it carefully, 127 is also not used actually. Right. You could see that after 120, 1 to 226, it should start with 127, right? It is not starting actually because 127 is again reserved for your loopback actually. 127 range is reserved for what is it? For loopback. Loopback, basically, you know, right? In your system, you have a NIC card, NIC card. And whenever you have a machine, when you are having an operating system, it understands the NIC card, and by default, what happens? The NIC card will have one interface which we call the LO, loopback interface, and always it will has an IP address like 127.0.0.1 like this, something like this. Suppose if you're having 2, 3 NIC cards in your system, NIC cards are there, like internet cards are there. So one NIC card will have this loopback address 127.0.0.1, and other NIC card will be having 127.0.0.2 like this. You'll be having. It depends upon the number of NIC cards what you have in your system, right? It depends upon. But by default, we see that in our laptop we'll have only one NIC card, and the default loopback address is always 127.0.0.1. So that is always reserved for the loopback. We can't use it for any other purpose. Right, sir? So as I said, right, your operating system or your OS or your computer operating system will only support class A, B, and class C IP addresses. Right? It cannot support, it will not support the class D and class C IP address. Okay, and it doesn't support what is it? Class D and class E IP address. Right? Even your computer system will not support even like broadcast also it not supports. Multicast also it will not support. These are not supported by your operating system. Correct, guys? And the class D and class C IP address, class D and class E IP addresses are reserved for multicasting. Multicasting organization like Wipro, sorry, not Wipro, ISRO, NASA, and many other research organization, REA research organization, they use it actually. So guys, multicasting is something like like recently, like 2 years back, like we had launched Chandrayaan, right? So Chandrayaan was launched on the moon, and Chandrayaan was connected with multiple different devices, multiple different systems actually, and the scientists know they can control the Chandrayaan from the multiple devices, multiple computers actually. So they were using all those multicasting IP addresses actually, right? It's not only controlled by one machine. The device is connected with multiple different device systems. No, here, so they were able to control from any of the different machine, any of the different machines actually, because they were using multicasting IP addresses, right? That's how it is. Am I clear, sir? Now, to tell you in a very basic way, guys, what is this public IP address and public and private? Now, consider that, like for example, at your home. So, you know that like actually this is my home network. Inside my home network, what happened, right? You will get one router here. So I'll have one router here. Like this is my router. This is my router. And in your home, no, you have so many devices. Like you have a laptop, you have something like a palm top. You are having mobiles, right? Mobiles. So many devices are there, right? In your at your home, right? Right. And now you know that basically, right? When whenever you are connecting device your device into your home network, each and every device will get an IP address actually. Each and every device will get an IP address. It gets what with some kind of a IP4 shaded range of IP address it might get. Like if you have seen it in your home, right? If you by default, if you connect your laptop within your home network to a Wi-Fi device, can you see here in your system you would have got an IP address from this range 192.168.1 dot something like 10 like that. You will get an IP address, right, with your to your laptop, right? Correct, guys? So this is in one of the shared range, IP4 shared range, you got an IP address to your laptop actually. Similarly, suppose if your wife, she's getting connected to a wife to the Wi-Fi, to the router actually, she will get one IP address for her device actually, mobile. Like 192.168.1.11 or 1.12, whatever. She'll get it actually like this. Right. And even your router will also get an IP address actually. Right. 192.168.1.1 IP address you get. So basically what happened, guys, your router will have two IP addresses actually. It has two IP addresses. It has a two IP addresses. One is nothing but we call it as an internal IP address. One is an external IP address actually. External IP addresses are not but the public IP address actually. Right? Internal IP address are nothing but whatever your private CID range is there, right? Private CID range is there, right? So through a private CID range, it gets one private IP address actually. This is the private IP address actually. Right? Now the thing is that actually, right, when you have any device, your operating system will not know what is an IP address has to be assigned to the device. As soon as your system or your laptop or anything it get connected to your network, which is there in your home network, automatically an IP address will get assigned actually. Right? Now, how it assigns an IP address? Basically, what happened, guys? I mean, you are having a router, right? A router will assign an IP address, but how a router will in turn assign an IP address? Basically, at the back end, what happened? Your internet service provider (ISP), what happened, right? They will set up one DHCP server in the back. Actually, the DHCP server, what it will do now? It will try to take from the DHCP server. It will try to take up one free available IP address and it will assign to that device actually. Similarly, one more device you are connecting, it will connect it, it will take from the DHCP server and assign to one IP address like this to that device. So hence what happened, right? You will see that in your home network, you would have connected with multiple different devices. Each and every device will get a unique IP address actually. And which will fall under the same like CID range, like 170, 192.160 dot in one dot something. So here this also 192.160.1.11. This will get 192.160.1.12. This will get 192.168.1.13. Like that it will get it actually. Am I clear, sir? So for example, in my case, if I try to check it out, what is it actually? We have one NCPA, right? What is it actually? Yeah, ncpa.cpl. So this is my Wi-Fi. So if you go and here, try to go with the status, and if you go to the details, can you see here? For my machine, I got 192.1.31.214. This is the IP address which has been assigned to my laptop, and this is the default gateway 192.1.31 watt, and this is the IP4 DHCP server, right? And this is a DNS server. So you could see that I got one IP address. Similarly, if my wife get connected with her mobile, she will get an IP address 192.1.31.215.216, whichever is available, it will be assigned to you. So here what is happening that the IPv4 or the private IP4 CAD range is 192.1.31.214. How I am able to get it that this is not, but this is my network 192.131.214, because you could see that my subnet mask is 255.255.255. So wherever we are seeing 255.255.255, 3 octets are fixed actually. So my network ID is 192.168.31. This is my network ID, and host ID is 214. So host ID is 0. It could be from 0 to 255 value. Am I clear, sir? Is it fine? Did you understood, guys, whatever I'm saying?
Yes, sir.
Okay. Now the thing is that now you got one public IP. Now, how you got the public IP? Your internet service provider, that is Reliance Jio, it has assigned some public IP for this router actually, right? So it means that Rajesh, this device can connect to the outside world, or it can send a packet to the outside world by using with the help of this IP, public IP. Right. So it means that when it is connecting, what is happening is that actually when it want to communicate, this device will communicate with 192.168.1.10 only. With this IP address only it will communicate. But it say that this device say that Rajesh, I want to connect. It say that I want to connect to the google.com. Okay, fine. It understand that okay, google.com is nothing but it is having some other IP address, right? We don't know. But that IP address, it doesn't belong to our network. Okay, it means that it is outside. So what happened? It sends a packet to the router actually. So router has the source saying that 192.168.1.10. This is the source IP who want to connect to the IP address of the google.com. So destination will be google.com's IP address. So while sending a packet, so the router understand, okay, this user with this IP address, he want to communicate to the outside world. Okay. Now the router will check whether I have some information about that IP address which is requesting for. That is number google's.com web page. Oh no, I doesn't have it. So router what happened? Through the public IP, it will attach the public IP address to the packet and it sends that packet to the outside world. Because through the public IP only, you can go and connect to the server where the Google page is hosted. Without the public IP, you cannot communicate to the outside world. So when the packet is getting moved, it also has. Now what he says that, okay, now Rajesh, all these days, it was traversing. Now from till here, what happened? The source was this one. With this IP address, he want to connect the Google's IP address actually. But since what happened, right? This packet, right? This packet, it has this information, source and destination. When it goes outside, you cannot simply send that packet because you need to have some information, the public IP. Public IP is assigned by the router. Now the routers will say that, okay, now I will send you to the outside world with the help of a public IP. Now what happened? This public IP address, whatever is there, right? It will attach to this packet. And that packet will be sent to the outside world. So now what happened when the packet is sent outside the world? Now this packet will go and it will try to reach to some router like this. Some external router. Oh, okay. From this particular IP, public IP address, he is requesting for this Google, but I don't have that Google page information. Please send it to some other further router. So it will keep sending to the next routers, next router, next router, until it gets information about that, which is that server, which is having that public IP address of the google.com page actually. So it go and it'll try to finally reach that server like this. So from here network, what happened guys, when you are communicating to the outside world, you are communicating with your own private IP address only. But as soon as it leaves from your route, right, a public IP address has to be attached. Now the thing is that You are having one device, you are having two devices, or you might be 100 devices. You might be having n number of devices here in your home network. All these end devices will be will be communicating with the same public IP only. Only one public IP only. Right? It doesn't mean that Rajesh, I have 255 devices, there has to be 255 public IP address. No, only one IP address is sufficient to communicate with to your internet actually. Right? Similarly, in your office network, you might be having 10,000 devices. This would be your office network, right? You might be having 10,000 devices, right, inside the office, right, or 10,000 computers or systems, right? Like this, right? Every machine will have an IP address, that is IPv4 private IP address you have. But whenever they want to communicate to the outside world, what happened? The company will purchase some four IP addresses actually. Four public IP addresses they'll purchase it. Right? So whatever the router which they are having, right, the router, it could be assigned with one public IP address or it could be assigned with a multiple public IP address. Say for example, if it is assigned with two public IP addresses actually. So all these 10,000 devices which is there in your company network, they can communicate to the outside world with the help of the two public IP addresses. This one public IP address and this one public IP address. Am I clear, sir? Is it fine?
Yes.
Yeah. Now the thing is that Rajesh, when I come back, when I come back here, can I get the information about the public IP address which is assigned to my router? Yes, sir. You can go to the Google and you can just say, what is my public IP? If you just go like this and if you hit to the browser, go to this link, what is my public IP? See, it will show you that this is the public IP of our, which is assigned by the Reliance. See, can you see here? 157.50.204.22. This is the public IP is assigned by the Reliance. If my wife know, if she opens her mobile and if she gives this URL, no, she will also get the same public IP. So with this single public IP, right? With the single public IP, what we are doing that we are able to communicate. So this router has this public IP. Who assigned it? Who assigns it? Your Reliance, your internet service provider has assigned this IP address for this one router. Clear, sir? So that is what we call an external IP address, right? Every router will have an external IP address because you want to communicate to the outside world, you need to have an external IP address. Without the public IP address, you cannot communicate to the outside world, right? And if you see it, watch it carefully here. I think if you come down, uh, city Nipani, Maharashtra. Okay, sir, I was supposed to tell something. Okay. When you are checking email, shopping, chatting, or blah blah, it is assigned by your internet service provider, allowing you to connect to the internet through a network. Whether at home, work, or go, your IP address can change easily when you switch to the network while traveling. Okay, not this one. A public IP address is a unique numerical label assigned to each device connect to the internet, allowing for identification and communication between device on a global scale. Okay. I was trying to say something. I was trying to show something. Okay, it's not there. Okay, leave it. Okay, sir. Okay. Now, now the question comes. Okay, fine, Rajesh. Now I understood something. It was something like a revision for you guys, right? It was something brush up for you, everyone, right? Now, what is the private IP and public IP? What is a private network and public network? Okay. So what is the difference between the private IP address and the public IP address? So guys, private IP address means actually, what is private IP address means? Private network means a network which cannot be accessed directly from internet. We call that as a private network. Public network is what? A network which can be accessed by internet or from internet is nothing but a public network. Am I clear on this, sir? Now, I have a question like uh, my system, my laptop, am I connected with the private network or public network?
Private.
Private. Any other answer? Why not public?
You connected to public server.
Connect to public IP, huh? Public network, right?
Yes, yes.
Huh? Okay. Now the thing is
Yes,
that, yeah, yeah. One is saying private IP address and other is public IP address. Yeah. Which is the one which you are connected? So guys, we have actually connected to the private network, not to the public network. Right. So because here what happened, we are under the home network, we are sitting here under our own private network and we are working. Whenever we want to access the outside world, right, we can access the outside world with the help of your device, which is router, and through a router we get a public IP address. Through the public IP address, you can go and connect to that particular server where you this particular public IP address. So where the particular server which you want to connect, right, like google.com, right, you can connect it, right. So it means that when you are trying to reach out to the internet actually, right, you will be sitting within your private network only and you will be reaching out. You can even sit with the public network also. For example, basically what happened, right, whenever you are having router guys, there are two types of IP address assigning is there. One is a static IP address and other is a dynamic IP address. Right. Whenever static IP address is something like where you will try to get where you try to get one static IP address, where you will try to get one public IP. That is called a static IP. So whenever any public IP address is assigned, which is not a static IP address, it leads to a cost actually. It means that it will lead to a lot of billing. You need to give per hour billing for that IP address which you are using it actually. Since it is too costly, we cannot go it. We'll go with a dynamic IP address, which is nothing but dynamically IP address, nothing but you will be provided some private IP address actually. So with the help of a private IP address, you need not to pay any money because it's freely available, right? You can use it actually, right? Say for example, if you are in a company, if you are having some 10,000 devices, as we discussed, you will say that Rajesh, I want to communicate with each other with all these devices. Shall we go and allocate 10,000 public IP address for all those 10,000 devices?
No.
If you try to go and ask for 10,000 public address, you will get it no problem. But how much cost you are giving? Everything is so much billed that per hour bill you have to give. Every hour, the billing of public address is 32 rupees per hour billing. Think that how much it will going to cost. So what they said, no, I don't want to do that. I will try to take up the private IP address only because to communicate within the network, we'll have a private IP address. Yeah, whenever we want to communicate outside world, then we need one public IP address. Yeah, then we can purchase some few public IP address. With the help of the few public IP address, we can route our connections, right? We can able to connect to the device actually. Now the thing is that actually that the websites like hdfc.com, icc.com, zomato.com, swiggy.com, right, bookmyshow.com, these websites or these applications are in the public network actually, because anyone from the outside they can connect to them actually, right? But whereas you are into the private, you are into private network, right? So suppose for example, assume that hdfc.com, that's which is the hdfc.com, which is then the public network. Suppose if that network or the person who's sitting in the hdfc.com, right, he want to connect to you with connect to your IP address which you are sitting at your home. Is it possible, guys, that person who's sitting from outside, who is in a public network, can he go and connect to a system? Say, for example, like I will go to some browser center. I will go and I'll open a web page and I will try to give an IP address such a way that I will try to connect to my laptop which is there in my home. Can I do it actually? No, you cannot do it actually, right? You cannot access any kind of a machine or a server which is in a private network actually from outside. Similarly, you can reach out to hdfc.com, icc.com because those are in a public network. They have to be in public network because they have to run their business, right? Any person outside what now he can able to access us. How they can access it? Because we are in a public network. Similarly, right, from the person who is there in outside in the public, he cannot connect to the private network because it's not possible because you are in a private network. You are in your own isolated network. Right. So as per the definition, the public network is network which can be accessed from the internet. Suppose assume that Rajesh, you say that this is my laptop. This laptop has, I got one public IP address, man. I got it. I took a public IP address by purchasing, by paying the money. Can anyone outside, can an SDFC back.com person, he can connect to you? Yeah, he can connect to you because you are in public network. now, right? Whenever any of your system, if you get any static IP address or public IP address, anyone outside, he can communicate directly to you. But when you are in a private network, nobody can able to communicate to you actually. So hence what happened, right? We are in a private network, not in a public network, right? Because we are sitting at a home. Similarly, all our company who are sitting inside the organization who got one, who got some IPv4 range address, right? They will be only on the private network. They cannot communicate to the public network. Public network can be communicated only when you are having on public IP address actually, and you will send your packet to a router. The router has all those firewall settings. If it allows you to connect to the outside world, it will allow that packet to be sent, and through that you will be able to connect from sitting inside your office. You can connect to the internet to any of the to any of the website or any of the applications actually, right? Now, okay, fine, guys. Now the thing is now for private network, there are predefined or reserved uh, reserved or can say CID range actually. It means that what are the private address range which we can use it actually, which are available, right? What are the CID range? So if you go to the Google and if you try to search for private CIDR range, where is it, sir? Yeah, this is a CID range, guys, right? If I try to copy it, or else snipping tool. This is my IPv4 CID range. This is what I can use it actually, right? So could see that from the class A 10.0.0.0 to 10.255.255, this I can use. This is nothing but your private CID range, which you can use it actually. The second is class B 170.16.0 to 170.31.255. You can use it. The class A address for 192.10.0.0 to 192.10.252. This you can use it. Apart from this three IPv4 private range. Apart from this, what are the other IP addresses are there? Excluding the class D and class E, what are the other IP addresses are there? Those all are public IP addresses. Am I clear, sir? These are the private IPv4 CIDR range. Apart from this, any other IPv4 address, all are public IP addresses. Is it fine, sir? Guys, did you understood? Sukit? Anand, sir, did you understood? Okay.
Yes, Rajesh.
Yeah. So
Sorry, I
now
was
what?
speaking in mute.
Yeah, no problem, no problem. Right. So this is what your range is. So now coming back here, I will write what is a CIDR range for IPv4 address. For IPv4 address, the CIDR range is 10.0.0.0/8 and 172.16.0.0/12 and 192.168.0.0/16. This is what you have a private CIDR range. Am I clear, sir? This is what we'll be using for the CIDR range, actually. Right? Now, guys, can you give me another half an hour more so that I will complete it? Is it fine with everyone? Naveen, Karthik, Anand, everyone? Fine?
Okay.
So,
Fine.
far
Sure,
no
sure,
confusion,
Rajesh.
right? So far no confusion, right? Everything is
No.
clear, right? Clear, right? Yeah. Otherwise, please go through this recording again one more time so that you will get clarified all your doubts, whatever you have. Okay, what is subnetting? What is subnet actually? See, subnet is something like your network can be divided into multiple smaller networks actually, called as subnets actually. See, for example, you might be having a large network in your organization, in your company, large network in your organization. But within your organization, there are many departments are there, right? Right? For example, IT department, right? For example, quality assurance department, right? Test, else for dev department, production department. Like that, you having so many departments, right? Right, each and every department should get some dedicated IP range, right? Actually, right, they want to get some kind of a dedicated range of IP address within the each and every department. So as a large organization, yeah, all these four divisions fall under the same organization only. But again, what happened, that you need to have your own network actually. So it means that you can take that whole large big network and you can divide among these four divisions actually. So this dividing the whole large network into smaller subdivision, that is what we call as a subnetting, or we call as a subnet. Similarly, if you go to the college, same thing, sir. If the college has a large network, big network is there. But again, within a college, there are so many divisions are there, right? So many departments are there, right? For example, CS department is there, mechanical department is there, right? Electronics department is there, as well as you are having some libraries there actually. So you're having so many different departments. For each and every department, you need to give some, you need to give some network, right? You need to give some CAD range, right? So you can take that whole large network and you can divide among these different departments actually. That is what we call the subnetting. So while subnetting, what you need to take care of two things is that one is that actually which is the IPv4 CAD range which I'm going to choose it. That is what first you need to decide that one. That's the first thing which you need to decide. The first thing is that what is an IPv4 private shader range I'm going to. Am I using this one or I'm using this one? I'm using this one. That is one criteria. So when you are performing subnetting, you need to consider the following points. What is it, sir? One is that how to choose which private IPv4 IPv4 CAD range. Okay, how to choose how to choose which IPv4 CAD range to select. Okay. Second is that like how many devices you are connecting, how many devices you are connecting in your network. This also is required. Okay. These are some criteria. There are other are there. I will tell you some of the other things, but these are the two important things which always choose it actually. Correct, sir? So now, can we take an example now? Can we just come up with a network like which is how you can design a network? Suppose, for example, you have been told that, okay, Rajesh, there is a building like this. There's a building. This is like a big building is there. In this big building, you are having some 4 floors like this. 1, 2, 3, and 4, whatever. Right? There are 4 floors are there like this actually. And you say that there are 4 floors are there, and each and every floor, let me take the example of 200 devices. You say that actually I want to connect some 200 devices in each and every floor. So each floor, first floor, second floor, third floor, fourth floor, each floor we should have 200 devices. Can you please design a network where you can accommodate this many? So totally how many devices? Guys, totally 800 devices, right? So 200 multiplied by 4 is 800. Total 800 devices you want to connect. So in that, there are 4 floors are there. Each floor should be connected with 200 devices. Now the question comes, right, Rajesh, right? Now, how I choose which is the IPv address which I have to choose actually? Which is the range? Either I have to choose this or this. Which is one which I have to choose? That is one question. And the second is that actually, like, I need to know even how many number of devices you are connecting. Yeah, how many number of devices you are connecting, that we have no information now, because I am connecting with 800 devices, right? Right? So now what happened? But each and every floor, there are 200 devices which are I'm connecting actually. Okay, good. Now I want to just do some calculation, right? So what I will do here, guys, I will just say that, okay, let me do one thing. Let me do the calculation here only, right? So each floor, how much you are connecting? You want to connect to 200 devices. So if you're connecting 200 devices, you know the formula how to calculate the subnet mask. What is it? 2 to the power of n is equal to 200. Am I clear, sir? Now, if you go back to the truth table here, and if you say that, Rajesh, what is the nearest value which is 200? Where is 200, sir? Can you go with the 2 to the power of 8? 256. 256 is greater than 200, right? Yeah. The value n is, what is it? N is, how much? N is 8 value. If the n is 8 value, what would be the capital N? Capital N will be 32 minus 8, which will be 24. Is it clear, sir? So this is for your each floor actually. For a complete building, how many number of devices are there, sir? 800, right? For the 800, what is the formula? Suppose I want to come with the subnet mask. I'll just say 2 to the power of n is equal to 800. So what is the value n where you need to check the nearest to 800? 800 nearest is which one? 2 to the power of 9, you cannot take it. You have to take 2 to the power of 10 only. Sorry, 2 to the power of, what is it? 2 to the power of 10 only, right? Because you have to connect 800, right? So yeah. So n is how much, guys? N is how much?
Yeah.
10. The small n is equal to 10. If small n is equal to 10, what is capital N? 32 minus 10 is how much? 22. Am I clear, sir? So now we'll come back here. So I'm taking an example now, right? Now consider a building with 4 floors. We need to design the network, right, which supports how much? 800 devices. Correct, right? So each floor requires 200 devices to be connected. Correct, right? So total building is how much? Is 800 devices. Am I clear, sir? Okay. So for the building, we came across with something n is equal to 22, right? Capital N is 22, right? Right? Capital N is 22, right? Correct, sir? For your entire building, I think, sorry, BUILDNG. Correct, sir? For entire building, what is the n value? 22, right? Right? Okay. Now the thing is that, guys, I want to ask you a small question here. Like, for example, assume that I'm having this two CADR notation, like 192.168.0.0/24, 192.168.0.0/25. Sir, can you tell me which is the CADR notation which is having more IP address range? Whether it's this one or this one? Can you tell me?
25.
Okay. Any other answer, sir? Which is the CADR notation which can accommodate more IP addresses? Because through this I can calculate the subnet, right? Which we saw already, right? Right. Let us see now. Like this, what is this? This value. This is not but the capital N, right? This is capital N, right? So here in this case, capital N is 24. What is small n? Then it is nothing but 32 minus 24, right? Which is nothing but your 8. You got it. Okay. So what is the 2 to the power of 8?
56.
2 to the power of 8 is How much, sir? 256, huh? I'll go with the truth table. 2 power of 256. Okay, fine. Now, here what happened? The n is equal to 25. The small n is equal to 32 minus 25 is how much? 7.
One,
What is 2 to the power of 7?
128.
2 to the power of 7? 128. So which is the CA direct notation which can accommodate more IP, more devices or more IPs? This one, right? So what you need to understand that the lesser the value, the more number of devices it connected. The more the value, it connects less devices. So this should be always be the less value. Then in that case, what happened that you can accommodate more number of devices. Like that you will understand, right? Am I clear, sir?
Yes.
Now coming back here. Here I'm having a 22 as an n. It means that n is nothing but the number of consecutive ones, right? Which is nothing but n, right? So now what happened? If I go here, if I try to check the range of this IP address, which is the value which is less than 22? Less than 22. All are less than 22 only, right? 16 is less than 22, 12 is less than 22, 8 is less than. So in that case, Rajesh, I can choose any one of this IP address. I can choose either this range or this range or this. Any one of this range I can choose for my designing the network actually. Correct, sir? So since n is 22, because how I arrived at the n 22? Because I'm taking the complete building, the n is 22. Right? So based on the value n, capital N 22, I am just checking which is the value which is less than 20. Suppose assume that this value is something like assume that the value is something like uh, suppose the value is something like 14. I'm just checking 14. Okay, 14. So now you will check that, Rajesh, this 14 is the capital value, which is the IPv6 private IP range where it is less than 14. So if you come over here, oh, is this 16 is less than 14? No, 16 greater than 14. Then it means that you cannot take this IPv4 range. You cannot take for designing this. Which one you can take it? 14 means I can take either this or I can take either this, because 14 is greater than 12 and 8 actually. Right? So the value whatever you're seeing is less than 14. That's what you can either go with this or with this actually. Am I clear, sir? Since it is 22 here, because my complete building, for my complete building as per diagram, the capital N value is 22. I'm just checking like which is the value which is less than 22. So all the three are 22, less than 22. I can choose any one of this actually. So let me choose this range 192.168.0.0. Let me choose it actually. So I will choose I have chosen the IPv CIDR, IPv4, IPv4 private IP address range, private IP address. I have chosen which one? 192.168.0.0. This is what I have chosen actually. So what I will do that, I'll just say 192.168.0.0. I have to use this 22, right? I have to say /22. Am I clear, sir? This is my, what is it? This is my building network CIDR range. Building network CIDR is nothing but 192.168.0.0/22. Okay, fine, good. What about the each floor? Each floor, what is the capital N, sir? According to here, what is the capital N, sir? 24, right? Am I clear, sir? It is 24. Right. Now, Rajesh, now the thing is that actually when it is capital N is 22, okay, it is for a building. So I need to calculate what is the building subnet actually. Building subnet mask. So if it is 22, there will be 22 ones, right? So it means that, Rajesh, it will be 1111. Let me copy it here somewhere from somewhere. I can't type it again. Right? How much, sir? It is 22 ones. Right? So guys, are you with me? Are you understanding, right? So I'm taking this complete range. So 22 ones, right? So I'm just calculating the subnet mask for my building, the whole building. For the subnet mask for the whole building is how much? It is 22 ones actually. So 8 plus 8, 16. 16 के बाद 17, 18, 19, 20, 21, 22, 23, 24. Rest two were zeros and other are 0. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 8. Is it fine, sir? This is their subnet mask for your building subnet mask is for this subnet mask. What about the floor subnet mask? Floor subnet mask. What is the value n? It is 24, right? So it means that 24 ones, right? So I'll just say, Rajesh, this is 111. So it means that 111. 24 means all these three octets will be 11 and this will be 0, 0, 0, 0, 0, 0, 0. Is it fine, sir? Now the thing is that actually that this first octet and second octet is fine in both the cases. There are no changes. Even the fourth octet is also 0, 0, 0, 0. Only the third octet here what happened, we are having 1, 1, 1, 1, 0, 0, 0, and here we are having 1, 1, 1, 1. So there is a difference here actually. Only this bit and this bit, the first two bit of your third octet is where the values are getting changed. Am I clear, sir? So here what happened? Sorry. So it is little tricky, guys. You need to understand this way only. So what you are saying that Rajesh, this is fine. This is a subnet mask for the whole building is this subnet mask, I understand. And for the floor, this is a subnet mask because I calculated with the capital N value, right? With that, I arrived with the subnet mask. Okay. Now, but when I compare with both the things, this first octet and the second octet and the fourth octet, I am not finding any issue. It is okay. But only with the third octet between these two, I am only finding these two values are changed. Because this is 1111, this is also 1111. I don't have any problem. Only these two bits only I'm having value. I'm seeing the change actually. So what you will say that, okay, let me consider that as something like XX. Correct, sir? Now, because it's a two value, zeros and ones, what is 2 to the power of 2? 2 to the power of 2 is 4, right? Right? It means that you will be having 4 combinations like this. 0, 0, 0, 1, 1, 0, 1, 1. Am I clear, sir? So now you are saying that, okay, Rajesh, now I want to calculate it actually, right? So we know now it is very clear. Now here what happened, guys? Now here what happened? Because it is a least significant value. It is least significant value, right? So here what happened? It's a least significant value, which is nothing but it will be 0, 0 means 0 only. 1, 0 means what is 1, 0? 1, 1, 0 is 1 only, right? 1, 0 is how much? 2 to the power of 1 is 1. Oh, so it is 2. So here what happened? 2 to the power of 0 is 1. 2 to the power of 2 is 2 to the power of 1 is 2. 2 plus 1 is 3, right? So
Yes.
the value is 0 and 1 and it is 2 and 3 actually, right? Now what happened? If you check it out, Rajesh, this is fixed, right? 192.1. This is fixed, right? This is fixed for me. I don't have any issue. Yeah. 192.168 is fixed for me, right? Then what happened here in the third octet, you are having 0. Yeah, 0 you write it. Plus, because this 2 bit is changing, this is fixed. I'm not touching this one. Only these two are only changing. So I'll mark it as a X actually. Dot. What is about this one, Rajesh? 0. Yeah, 0. Like this. Slash. Because we are calculating for the each flow, right? This will be the 24 value. Oh my God. Oh. This will be the 24 value. So this is 22 for the whole building. What about the each subnet mask? The capital value is 24, right? You have to do this is right. Now what happened, right? Now for the second one, how do you guys? So now how you calculate? 192.168.0, 0. Okay. This X is 0, 0, right? So we'll consider 0 only. This is what?
1.
1, right? Yeah, it will be 1. Dot 0 slash 24. 192.168 dot. What is it actually? 0 plus. What is 2, 1, 2, 1, 0? It is 2, right?
2.
Yeah. 192.168.0 plus, what is it? 1 is how much? 3, right? Yeah, like this. So now what happened, guys? You got this range actually. 192.168.0.0/24, 192.168.1.0/24, 192.168.1 dot, not sorry, 2.0/24, and 192.168.3.0/24. This is what you will be giving. This is what the network you will be giving it. It means that for each and every, this is like first floor. This is will be this one. This is what your CADR notation for the second floor, third floor, and the fourth floor, like this. Am I clear, sir? Now, so our building, whatever the building is there, right? Right, this first floor, we will give this as a range actually. So here what happened, right? You can connect, this is the IP address range, you will take it, and you can connect up to 200 devices in this first floor. Same thing in the second floor. The network will start with, this one will start with 192.168.0.0. This one will start with 192.168.1.0, like that. You can connect up to 200 devices like this. Similarly, the third floor is like this, and fourth floor. Got it, sir? I know it is little bit tricky, but this is how you need to resolve it actually. This is how you need to come up with the design actually. So now, sir, if any interviewer asks you, can you calculate these things easily? If we say that, okay, I need to design this, okay, give me how many floors are there, or what is it actually? He's saying that, sir, there is no floor at all. Okay, there are no floor. Okay, it's no problem. Oh, okay. You tell me like how many devices you need. Okay, he'll say something. Now you start calculating. You have this formula, 2 to the power of n, something like that. Then you come up with the range actually. And then like with the capital N value, you have to decide which is the IPv4 range you have to choose it. Okay, either this or this based on the capital N value. So whatever the capital N value you are getting, okay, and what else thing that should be, here the value should be less than that actually. Yeah. If it is more than that, actually don't consider that one. Whichever is less than, consider that IPv4 range. Actually. In our case, it is 22. 22 is actually, is there any value which is less than 22? 22, all these values are less than 22 only, right? So you can choose any one of this actually. Am I clear, sir? Sir, can you take one more example?
Yes.
Right. So guys, are you finding interesting, or see, it's little clumsy as I said earlier, but only is that actually you need to just just what happened, practice 2-3 times. 100% what happened in some interviews, they'll ask you, okay, simply they'll ask you to just check your networking skills, like how much I need to design this network, man, how you're going to come up, can you tell me? Whatever I explained so far, the same thing you have to tell in interview. He'll be very much impressed if you try to explain about all these things actually. Right? Don't do anything speculation and all. Just to tell that, okay, can I share my screen? Yes, sir. Can I write it in the paper, on the white paper or ebook? Yeah, you please write, he'll say. Because it's all your, it is something like you need to put in a paper and show him actually. You cannot explain orally like this. Okay, this like this. He will not, he will understand or not, that is different. He will not be able to completely understand if you are even saying it orally. If you tell it in a paper wise, or else if you share your screen and explain about this, that this is how you can do it, then he will get impressed actually. He will say, okay, no problem, and I don't have any issue. Like this, if you tell all these things, he'll be very happy. He will not ask any question. On networking itself, he will not ask you any question actually. Okay, we'll take one more example. Then I think we will, already it's been 10 o'clock, guys. I mean, I'll take one more example. Suppose, for example, consider each floor, consider each floor, what is it? Requires uh, 20,000 devices. 20,000 devices. Okay. And I'll take the same floor. There are 4 floors. We can take anything. We can take 8 floors or 16 floors. Whatever the number you want, you can take it. For our simplicity, I'm just taking again the same 4 floors itself actually. right? So now the guys, now that now let us try to calculate now what would be the network you're going to design. Each floor is how much you're taking, you're considering as a 20,000, right? Right. So what is it? 2 to the power of n is nothing but 20,000. Right. Now, what would be the nearest value for 20,000? If you go to the power table, what's the nearest value? 16,000, you cannot accommodate. 20,000, yeah, 2 to the power of 15, right? Is nothing but 32,000, right? So n is nothing but here, capital N is nothing but, sorry, small n is nothing but, it is 15 actually. Capital N is how much? 32 minus 15, right? How much it will get? You will get 17. Correct, sir? Am I clear till here? Okay. What about the building, the total building? Since there are 4 floors, 20,000 multiplied by 4 is how much? 80,000, right? So total in the building, there are 80,000 devices are there. Right? If there are 80 devices, what would be the formula? 2 to the power of n is nothing but 80,000, right? Right. Now, what would be the nearest value? Nearest value is how much for 80,000? It is nothing but your 2 to the power of 17, right? It is 1,31,000 something like that, right? Like that would be the nearest. If you take it 2 to the power of 16, it is 65,000, which is less than 80,000. So you can't consider this value. You have to consider the next highest value, which is, so n is 17. A small n is 17. What would be the capital N? Capital N will be 32 minus 17 is equal to 15. Right? So for your complete building, n is equal to 15. For each floor, n is how much? Each floor, n is 17. Am I clear, sir? Because we are designing for the whole building, I need to select one IPv4 shared range where it supports for my entire building, which is number, it supports for your entire 80,000. 80,000 device it has to connect, right? But each floor is 20,000, right? So now I got the value n. So can we check in a shared range, which is the value n, which is less than 15? Come here. So less than 15, this is 16, this is greater than 15, right? I can't consider this network. I can't choose this one. So next is which one? Yeah, this one. Either I can go with this or with this. Did you understood, guys? Because here the value is 15. I need to choose an IPv4 address where the value n should be less than whatever it is there. So whatever the existing IPv4 serial range is there, right? I need to check it. But here this one, this is 16, which is greater than 15. I can't choose this network, or I can't choose this IPv4 shared range, private shared range. Then I have to go with this one or either this one. So let me choose 172 itself actually. Let me choose with the 172.16.0. So coming back here, now you have to say that Rajesh, my building network CIDR range is 172.16.0.0/15 because this is 15, right? Clear, sir? Is it fine? So now, so if it is 15, what would be the subnet mask for, what is the building subnet mask? Subnet mask, sir. The building subnet mask is how much? So 15 ones, right? So I'll just choose like the 15 ones actually. So this is 8, 8 plus 8 is 16, but it is 15 is saying, so I'll just say 0 dot 1 2 3 4 1 2 3 4 dot 1 2 3 4 1 2 3 4. This is a subnet mask, right, for my entire building. Is it clear, sir? Now what about my floor? Because each floor is 20,000 and the value n is 17, capital N is 17. Okay, now I know that actually for my floor, the subnet mask is how much, sir? It is 17, right? So what you will say that, Rajesh, I'll take this one. 8 plus 8 is 16. Yeah, sorry. 16. 8 plus 8, 16 plus 17. Because it is n is 17, capital N is 17, right? Then remaining would be 0. 1, 2, 3, 1, 2, 3, 4. Dot 1, 2, 3, 4, 1, 2, 3, 4. This is my subnet for the building. Now, if you watch it carefully, which what it carefully, the first octet and the second octet, there is no issue with that. Only with the second octet and the third octet there is change, right? In the third octet, this is getting changed, and in the second octet, this is getting changed. So what you need to understand very carefully, guys, we have to very understand that Rajesh, in the third octet, right? In the third octet, the the highest significant bit is getting changed actually, right? This is what you recognize. And in the second octet, the lowest significant bit got changed actually, right? So here the lowest is getting changed, and here in this case the highest is getting changed. Okay, I got it now. Now what I will do that, I will just, so what you're saying that here, this is all fine. In the second bit, actually, in the second octet, only this value is getting changed. I'll call this as an X. After that, after here, in the third octet, this one is getting changed actually. Clear, sir? So it means that Rajesh, there are only two values are there which are getting changed. It means the two values. So 2 to the power of 2 is 4. So you will have 4 combinations, right? It will be 0.0, 0.1, 1.0, 1.1. Am I clear, sir? All other remaining are okay, right? This one, and all is, this is and all is fine, right? This and all is fine. Only this only bit are only getting changed. So in the second bit, in the second bit, and in the second octet, this is getting changed, and in the third octet, this is getting changed. Right? Now, how we are going to come up? You'll say that, okay, Rajesh. Now what happened? This one is 172, right? This write as it is actually 172 dot, okay, 16, okay, of X actually. 16 of X. So here it is 0 only, right? The first value is 0 only. You consider as a 0 only. 0 dot. This is what? What about this one? This one also, here what happened? The first value is 0 only. You will consider that as a 0 only. 0.0 slash. Because it's each floor, right? Each floor is value 17, right? But to just say slash 17. Okay. What is the second value? 172 dot. This is the second octet 16, right? 16 plus. This is 0 only, right? 0. Okay. But here, this is 1, right? Here, what happened? If it is 1, rest all are 0. If it is 1, what would be the value? It is 120, right?
120.
If you try to, yeah, if you try to take the whole thing like this and go over here and try to go with the, from the binary to the decimal, you got 128. So this is 128. This is 128 dot 0 slash 17. 172 dot 16 plus, because this is 1, right? So 1 is nothing but what? 2 to the power of 0 is 1, right? It is 1, right? So 1 plus 16 plus 1 actually. Dot, this is 0, 0.0 slash 17. This is how much? 172, right? Dot 172 dot 16, right? This is 2 to the power of 0 is 1, right? So you'll take 1, right? And this is what is 2 to the power of, 2 to the power of this one, this is not but 128 only, right? 128 dot 0 slash 17. So now what you got, guys? You got a IP address like this. 172, 16 plus 0 is 16, 16 dot 0.0 slash 17, 172 dot 16 plus 0 16 dot 128.0 slash 17, 172 dot 16, 1 plus is 17, right? 17 dot 0.0 slash 17, and 172 dot 17 dot 128.0 slash 17. These are your network design, guys. So it means that this is the subnet you're going to give. This is a CIDR for your first floor, second floor, third floor, and the fourth floor. So by using this way, you're not wasting your IP address. You are accurately using your, very less IP address are wasted, not much actually. right? So the idea behind using the subnetting is that subnetting will avoid any kind of wastage of the IP addresses actually, right? So this is how. So if you take the first floor, you will give this a shader range for the first floor, second floor for this, third floor for this, and fourth floor for this. Am I clear, sir? So now we can easily come up, right? Okay. So this is an assignment for you. Do it tomorrow. And if you're not able to do it, I will do it. Okay. What is an assignment? Consider a building with 8 floors. 8 floors. Each floor requires some 60 devices. Right? There are 8 floors are there. Each and every floor we need a 60 devices. Okay. Design the network actually. Can you do this, guys? This is an assignment. So today I gave some 2 assignment. One was with the calculating the subnet mask. That anyway it's easy. This is also quite easy. Right? You have to take as 8 actually. So in 8 means actually like this way you are having 4, 1, 2, 3, 4. Like that you will get 8. You'll get 8 subnets. You're going 8 CAD range you're going to get actually. Right? So first with this you need to come up with like which is the CAD range which you're going to choose it actually. So in your case I think it'll hit up here because you'll be choosing 10 dot series CAD range for this your requirement. Like you will choose that and then like you can go with the calculating like this actually. Okay, building subnet mask, floor subnet mask, and then and come up here. In this case what happens, since it is 8 floors are there and since it is 60 devices, right, it will try to change. There are three. Here it is 2 octet. 2 values are getting changed. It will show 3 actually. Like this 2 will get changed here in the second octet, and 1 it will get in change. Like this you will get some 3 values. So 2 to the power of 3 is how much? 8, right? 2 to the power of 3 is 8, right? So you will get 8 like this: 0, 0, 0, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. Like that you will get 8. You'll get a 8 value, right? Like that. So you need to calculate based on whatever you got the IP address, right? You need to choose it actually. If you don't know, let me know. I will do it actually in tomorrow's session. Right? Is it fine, guys? So, guys, I hope that you understood this subnetting. Okay, please practice it. Try to take you yourself can choose any kind of values and then like just open a paper. I mean, take a paper and paper and pen, write down it everything, right? So that you will get some. So once you do 2, 3 times like this practice, no, you will become a little bit perfect in this, and then you can able to answer any kind of a question when it comes to the subnetting. Right. Usually they don't ask. For me, one of the person had asked in one company, like I answered him everything. Like he didn't told anything. He said, okay, okay, like that he told me. Okay, so I explained all these things to him. I shared my screen and I opened a notepad and explained all the things. How do you create a network like this? Then he said, okay, fine. So if you try telling like this, no, nobody will ask you any question actually. Fine, guys. So, guys, I hope that today's class was fruitful for all of you. Okay. Thank you then. If there are any questions, no questions, we can wind up. And today evening, we are going to meet for the Git session.
No.
Okay. Anant, Navin, sir, everyone, Navin, all are okay? Om, everyone?
Yes. Evening 7 o'clock.
Evening, can we make it at 5 o'clock? 5 p.m., 5 p.m.
That's
evening?
fine. It
5 to
little
6.
early.
Yeah, 5 to p.m. 5 p.m. to 6:30 p.m.
Yes, yes, Rajesh.
Okay, we'll have at 5 p.m. today.
Okay.
Again,
Thank you.
tomorrow we are having morning, guys. Tomorrow again we'll have a
Yeah,
AWS,
sure.
right? Tomorrow we're starting with VPC. If that's what I said, like please try to come up with this. If not, like let me start tomorrow's session with this only. First 10-15 minutes I'll take to explain this, and then we'll start with the VPC.
Sure.
Okay. Thank you then.
Thank
Bye
you.
bye.
Thank you.
Let me stop the
5 o'clock,
recording.
right?
Yeah,
Evening
today
5
evening.
o'clock.
I will put everything in the message in the group, sir. Don't worry.
Okay. Thank
In
you.
group, all I will mention it. Bye bye.